All right, let's talk about the verifying solutions. Since finding the solution from scratch is fairly difficult, let's just say somebody already found a solution and we want to verify that that is actually a solution. All right, so here's the differential equation. This is problem number 12. X squared y double prime minus x times y prime plus 2y equals 0. Right, so let's verify the first solution, y1, and y2 is going to be very similar, so I'm going to just do y1. All right, let's verify that the y1, which is x times cosine of natural log of x, is actually the solution of this given differential equation. All right, so since we need to know first derivative and the second derivative, so let's find the first derivative first. So we have y1 prime, so y1 prime is equal to, all right, so since you have two things multiplied together, we're gonna, all right, this is the first guy, this is the second guy, so we have to use the product rule to find the derivative. All right, so derivative of the first guy is 1 times the second guy, which is cosine of natural log of x, and plus first guy is x times derivative of cosine of natural log of x would be, derivative of cosine is negative sine, and then inside is natural log of x, then you multiply by derivative of natural log of x, which is 1 over x. Right, so we have that. All right, so we can cancel x here on top, and here's the x on the bottom, and we can clean this up. So you're going to get, let's say you have a cosine of natural log of x. All right, here's you're going to have a minus sine of natural log of x. Right, so that's the first derivative. Right, we need second derivative as well, so we have y1 double prime is going to be, right, derivative cosine of natural log of x would be negative sine of natural log of x. Then you have to multiply by derivative of the inside function, natural log, so it's going to be 1 over x. All right, negative sine of x, sine of natural log of x, derivative would be negative cosine of natural log of x, right, times 1 over x. Right, so since we have negative 1 over x is in common, so I'm going to actually go ahead and pull out the negative 1 over x. Right, then you have sine of natural log of x and a plus cosine of natural log of x. All right, so we found the first derivative and second derivative, so all we have to do is plug them in to see if we get the 0 on the right hand side. All right, so let's start with the left hand side of the differential equation. All right, so it's going to be x squared times the second derivative. So you have x squared, so x squared, and times the second derivative here. So second derivative came out to be negative 1 over x, and then we have sine of natural log of x and plus cosine of natural log of x. All right, so that's the first term. And second term, I'm going to go probably here. So it's going to be x times, and the first derivative is cosine of natural log of x minus sine of natural log of x. All right, that's the second term. And the last term is 2 times y1. So it's going to be x cosine of natural log of x, right? So let's simplify to see if you can cancel things out. All right, so we have, let's see, we can cancel x on the bottom and one of the x here. So I'm going to just scratch out the square there. And then I'm going to just multiply out and write down. And so you have x times negative sine of natural log of x. So it's going to be negative x sine of natural log of x. All right, negative x cosine of natural log of x. And then you have a minus x cosine of natural log of x. All right, negative, negative, so it's going to be plus x sine of natural log of x. Then you have a last term, 2 times x cosine of natural log of x. All right, so let's see what we can cancel out. So you have a negative x sine natural log of x. There's a positive x sine natural log of x. And we have a negative x cosine, negative x cosine. So there are 2 of these guys. And then you have a positive 2x cosine of natural log of x. So therefore, this will give you 0 because everything is canceled out, which is the right hand side that we are looking for. Right? So this will verify that y1 satisfies this differential equation. Right? As I said, the y2 is exactly the same. Find the y2 prime and the y2 double prime and plug them in to see if you can get the 0 on the other side. All right, that's it. I hope that this was clear.